Right now, in every direction around you, the space just beyond our sun is hiding its closest secrets. Look up on a clear night, and it seems almost empty. But that darkness is not empty at all. Drifting within a few dozen light years of us are dim red stars you cannot see with your eyes, frozen worlds, and stars so strange they seem to break the rules. Some of these neighbors may cradle oceans and the faint chance of life. Others would tear apart anything that came too close. Our nearest neighbor is not even a single star, but three tangled together, and one of the worlds circling them may hold liquid water. And on a few of these worlds, you would look up and see not one sun in the sky, but 2 or 4 or 6. These are our neighbors, and they are stranger and more varied than the night sky ever lets on. One question runs through all of them: which could be alive, and which could kill anything that tried to live there. Chapter 1: Stepping Out of the Sun's Light. Compared to the great galaxies and star clusters scattered across the universe, our whole solar system is barely a speck of dust, and yet, for us, it has always been the entire world. Everyone who has ever lived, every story ever told, every ocean and mountain and quiet evening like this one, all of it has unfolded around a single ordinary star, in a single small pocket of a single arm of one galaxy among billions. So before we travel, it helps to sit for a moment with just how crowded or how lonely that little pocket of space really is. Within about 15 light years of the sun, astronomers have carefully mapped roughly 50 separate star systems. Some are lone stars like ours, drifting by themselves through the dark. Others come in pairs, or threes, bound together by gravity and slowly circling a shared center, locked in a dance that has been going on far longer than there have been eyes to watch it. All told, that small bubble of space holds around 65 stars. Said out loud, it sounds like a busy neighborhood, a place where the streetlights are close together and someone is always nearby. But space is patient with its distances. Out here, the word neighbor means something very different from what it means at home. Let me try to make it real, because the numbers alone will slide right past you. Imagine shrinking our sun down until it was a single grain of sand held in the palm of your hand. On that scale, the very nearest star would be another grain of sand, sitting roughly 40 kilometers away, about 25 miles. 2 tiny grains, one in your hand and one on the far side of a city, with nothing but empty air in between. That is the kind of emptiness we are about to cross, and it is worth letting that sink in, slowly, because our minds are simply not built to feel a distance like that. We can picture the far side of a city. We cannot really picture a grain of sand that far away, floating alone in the dark, and then hold in the same thought that this is the closest thing there is, the nearest of all our neighbors, the short trip, the easy one. Everything else is farther. Some of the worlds we will visit are 10 times that distance, or 20 or more. If our sun is a single grain of sand in your palm, then most of this whole journey unfolds across a landscape the size of a small country, with nothing in it but a scattering of lonely grains, each one a blazing sun, each one separated from the next by an ocean of empty nothing. That is not a flaw in the universe. It is simply how thinly the stars are spread, and it is the first thing you have to make peace with out here, that space is mostly, overwhelmingly, tenderly empty. And even that picture is generous, because the truth is, these stars are not just far apart in space, they are far apart in time as well. Think about what starlight really is. The light carrying each of these stars to your eyes is old. It left some of them 4 years ago, and others 50 years ago or more, and it has been traveling ever since, crossing all that emptiness at the fastest speed the universe allows, just to arrive at your eye in this quiet moment. Some of that light began its journey before you were born. When you look up at the closest stars, then, you are not seeing them as they are. You are seeing them as they were. You are, in the gentlest possible way, gazing into the past. The night sky is less a photograph than a long, slow letter, still arriving. There is a gentle kind of vertigo in that, if you let yourself feel it. Look at any bright star, and the light landing softly on your eye, set out on its journey while the world was a different place. Some of it left before you were born. Some left while your grandparents were young. The star may have flared, or dimmed, or drifted since, and you would have no way to know, because the news of it is still crossing the gulf between you, still years or decades from arrival. In a very real sense, the night sky is not a live view at all. It is a vast collection of old photographs, each one taken at a different moment in the past, all of them pinned up together on the same dark ceiling and mistaken for the present. When you lie back and look up, you are not seeing the universe as it is. You are seeing 1,000 different yesterdays, all at once. And here is the strangest part of all. Most of the stars nearest to us are ones you have never seen and never will, at least not without a telescope. They are red dwarfs, small, cool, dim embers of stars that give off so little light they stay completely invisible to the naked eye. They are by far the most common kind of star in the galaxy, and they crowd our neighborhood, and yet they hang there unseen, quietly burning away for tens of billions of years. The bright, familiar stars that fill our night sky, the ones we name and draw into constellations, are mostly giants, blazing away from far greater distances. They only look close because they are so luminous. Our true neighbors are the quiet ones, the faint ones, hiding in plain sight just beyond the reach of the eye. So the sky you think you know is a little bit of an illusion. The real story of what surrounds us is written in stars too faint to notice, and to read it, we have to leave home. We will move slowly outward, star by star, letting the sun shrink behind us until it becomes just one more point of light among all the rest, no brighter or more important looking than any of its neighbors. It is a humbling thing to imagine, watching our own star dwindle until you could lose it in the crowd. But it is also the only way to truly see where we live. The stars we are about to reach have waited billions of years already, scattered across distances so vast that the journey to each of them stretches out on its own. Moving outward from the sun means crossing that emptiness world by world, letting each one come into view in turn, until our own star is only a memory behind us, and the whole strange neighborhood lies open ahead. It helps to hold our own home in mind as a point of comparison: the warm yellow sun, the blue sky, the steady ground. That familiar world is the shape against which everything else out here is measured, and the real surprise of a journey like this is not how alien the other worlds turn out to be. It is how, again and again, they send us looking back at our own quiet corner with new eyes. It is worth pausing too, on how recently we have been able to draw this map at all. For almost the whole of human history, the stars were simply lights, fixed, unreachable, without depth or distance. Looking up, our ancestors had no way to tell whether a bright star was small and close or vast and unimaginably far. A dim star and a brilliant one might sit side by side in a constellation and be nothing alike, one a near neighbor and the other a giant blazing across half the galaxy. It is only within the last century or two that we learn to measure the true distances to the nearest stars at all, by watching them shift ever so slightly against the far background as the Earth swung from one side of its orbit to the other, like holding up a thumb and blinking one eye and then the other. And it is only within the last few decades, within many of our own lifetimes, that we have begun to fill this neighborhood in with actual worlds, sensing distant planets by the faint wobble they give their stars, or the tiny dimming as they cross in front. The map we are about to travel is one of the newest things human beings have ever made. Nearly everything we are about to see would have been completely unknown to anyone born much before you were. We are, in a real sense, the first generation that gets to take this particular walk. Think about that for a moment, because it is easy to rush past. Every person who ever lived before the last century or so looked up at these same nearby stars and simply could not know what we are about to learn here. They could not know that the closest one is really 3, or that a rocky world circles the faintest of them, or that a nearby star races across the sky, or that another holds a sky of 6 suns. All of that was hidden, utterly, behind points of light that gave nothing away. We happened to be alive at the exact moment the answers started arriving. That is an extraordinary piece of timing, and it is worth a little gratitude to be here, now, in the first generation that gets to actually see the neighborhood, rather than only guess at it. So we travel now not only outward through space, but forward through everything we have so recently learned to see. Our first stop is not quite the closest star of all. We will save that small surprise for just a moment. But the direction we travel first will already begin to answer the question we are carrying. Because out here, some of these worlds are gentle and some are not. Before we go far, though, we really should meet the closest of all, and it is not the single, lonely star you might expect. Chapter 2: Alpha Centauri, the neighbor next door. When people picture the nearest star to the sun, they usually imagine a single point of light, alone in the dark, the way our own sun looks alone in its patch of sky. The truth is stranger and far more inviting. Our closest stellar neighbor is not one star at all. It is 3 of them, woven together into a single system we call Alpha Centauri, a little over 4 light-years away. That makes it the closest doorstep in the entire galaxy for us. For as long as human beings have dreamed of reaching another star, this is the door we have imagined knocking on first, simply because it is nearest. Every story we have ever told about traveling to the stars, every imagined voyage, tends to point here first, to this one system, because it is the closest shore across the great dark ocean. If humanity ever does leave the sun behind and set out for another star, the odds are overwhelming that Alpha Centauri is where we will aim. So it is worth getting to know it well. This is not just any neighbor. It is, in a sense, the first rung of a ladder we have only just begun to imagine climbing. And it is a humbling first rung, because even it is so far away. 4 light years sounds almost cozy after all our talk of vast distances, the closest thing there is. But remember what it really means. Light itself, the fastest thing in the universe, takes 4 years to make the crossing. The swiftest craft we have ever launched would take tens of thousands. That is the sobering shape of the gulf between stars, drawn at its very narrowest. If even the nearest doorstep lies that far off, then the neighborhood we are touring is less a place we could ever visit than a place we are privileged to know about at all. A set of postcards from the dark, arriving at the speed of light, from shores no human foot will touch for a very long time to come. 2 of these stars, Alpha Centauri A and B, are close cousins of our own sun, so similar that if you were dropped into their system without being told, you might mistake them for home. They circle each other in a slow, elegant dance that takes about 80 years to complete a single turn, one of them a touch brighter than the sun, the other a touch fainter and more golden. 80 years, about the length of a long human life. A person born on a world in that system might watch the 2 suns swing all the way around each other exactly once, from close embrace to far separation and back, over the whole span of their lifetime, and never see the pattern repeat. Picture, for a moment, standing on an imaginary world orbiting one of them. Your day would be lit by a sun much like the one you know, warm and yellow-white, familiar enough. But at certain times of year, a second sun would join it in the sky, not a distant point of light, but a fierce, brilliant star, far brighter than anything in our own night sky, bright enough to cast a soft second shadow at your feet. Imagine your own shadow doubled, 2 faint copies of yourself stretching out in slightly different directions across the ground. Imagine an evening where one sun has set, painting the horizon in ordinary colors, while the other still burns high overhead, so that darkness never quite comes, and the night is really only a kind of deep, glowing dusk. There would be seasons of 2 suns and seasons of 1, tides of light rising and falling across the years, as the second star drew near, and then wandered away again. 2 suns, and never quite full darkness. That alone would be wonder enough for one world. But the real prize of this system is not either of those 2 bright stars. It is the third one, the faint one, the one you would actually have to search the sky to find. That third star is Proxima Centauri, a small red dwarf drifting at the outer edge of the group, only loosely bound to its 2 brighter siblings. It is the single closest star to our sun of all, our nearest stellar neighbor in the whole universe, and yet it is so dim that no human eye has ever seen it without a telescope. It is a quiet ember of a star, and circling that quiet ember, astronomers have found worlds. The most famous of them is Proxima Centauri B, a rocky planet with a mass at least a little greater than Earth's. It sweeps around its star once every 11 days or so, at a distance of only about 7.5 million kilometers, roughly 5 million miles. Around a star like our sun, an orbit that tight would be an inferno. But Proxima is so cool and so dim that this snug little orbit places the planet squarely in the habitable zone, that narrow band around a star where the temperature is just right for liquid water to pool on a surface rather than boiling away or freezing solid. Sit with that for a second. The very nearest planet to Earth, Out of all the billions upon billions in the galaxy, maybe a world where rain could fall, where water could gather into pools and seas. Of all the addresses in the cosmos, the one right next door is one where the door might not be locked. It is worth remembering how hard won that knowledge was, because it did not come from a photograph. No telescope simply took a picture of Proxima B. Instead, astronomers watched the star itself for years, hunting for the faintest imaginable wobble, the tiny rhythmic tug of an unseen planet pulling its star back and forth by a few footsteps worth of speed across light years of distance. Teasing that whisper of motion out of the noise took extraordinary patience and instruments of almost unbelievable precision. And when the answer finally came, it was quietly historic. The nearest star to our sun had a planet, and that planet sat where water could survive. Of all the places such a discovery could have landed, it landed on our very doorstep. Sometimes the universe is generous with its coincidences, and this planet is not alone in its system. In more recent years, astronomers picked up the faint signal of a second, even smaller world, Proxima D, a feather-light planet only about a quarter the mass of Earth, whirling around the star in a mere 5 days. That signal was so delicate that it took years to trust. First reported as a hint a few years ago, it was finally confirmed with an entirely separate instrument in 2025, a quiet triumph of patience and precision. So, the closest star to our sun is not a lonely point of light after all. It is a small planetary family, with at least one member sitting exactly where water could survive. But here our question returns, and here is where hope runs straight into hard reality. Proxima Centauri is a flare star. Every so often, without any warning, it erupts. It blasts out ultraviolet light and X-rays in sudden, violent outbursts, far stronger, relative to its size, than anything our steady, well-behaved sun ever throws at us. And Proxima B orbits so close to its star that when one of those flares goes off, the planet is bathed in that radiation, again and again, across the ages. Over millions of years, those repeated floods of energy may have peeled the planet's atmosphere away entirely, stripping it down to bare, scoured rock. So Proxima B is a haunting kind of place to think about. It is the nearest world to us where liquid water might exist, and, at the very same time, a world that may have been sterilized clean long before life ever had the chance to begin. Close, familiar, tantalizing, and possibly quite dead all at once. It is a reminder that being in the habitable zone is only the beginning of the story, not the end of it. And yet, even knowing that Proxima B may be a scoured and lifeless place, it is hard not to feel a pull toward it. There is something almost unbearably close about it. 4 light years is still an impossible distance by any human measure. If you set out today on the fastest spacecraft we have ever built, you would not arrive for tens of thousands of years, longer than all of recorded history stretched end to end. And yet, on the scale of the galaxy, 4 light years is nothing at all. It is the very next doorstep. If the Milky Way were a great city, Proxima would be the house immediately next to ours, close enough to see the light in its windows. To know that there is a rocky world right there, right next door, sitting where water could pool, and to know that we may never, in any of our lifetimes, truly reach it, is a particular kind of ache. It is the ache of standing at a window, looking at something beautiful just outside, with the glass between you and it. And yet, even that ache is a kind of privilege. To be able to stand at the window at all, to know there is something out there worth aching for, to have measured the world beyond the glass and found it real. Our ancestors could not even do that much. The distance is the same distance it always was. What has changed is that we can finally see across it and name what we see and let ourselves long for it. That longing, in its quiet way, is one of the more human things we do, to look at the unreachable and love it anyway. Even so, this system pulls at us like no other place in the sky. It is near enough that, for the first time in history, we have begun to dream seriously and concretely about actually reaching it. One project, called Breakthrough Starshot, has studied sending not a great heavy ship, but a swarm of tiny probes, each one no larger than a computer chip, each riding on a gossamer sail pushed by a battery of powerful lasers fired from Earth. The idea is to accelerate these feather light travelers to a fair fraction of the speed of light itself, so that they could cross those 4 light years, not in tens of thousands of years, as an ordinary rocket would need, but in something like 20. It is an audacious plan, still far from anything we can build today. But the fact that we are seriously working on it at all, the fact that reaching another star has moved from pure fantasy into engineering studies, is entirely because Alpha Centauri is close enough to make the dream feel almost touchable. And even if those tiny probes are never built, even if no machine from Earth ever crosses that gulf, there is something worth holding on to in the simple fact that we tried to imagine it. For all of human history, until almost yesterday, the stars were fixed and untouchable, as far beyond reach as heaven itself. To have reached the point where we can seriously sketch a route to another sun, to name the star, measure its planet, and begin drawing the map, is its own kind of quiet milestone. We may be the first generation that could point at a specific star, a real place with real worlds, and say, honestly, that is where we might one day go. The distance has not shrunk, but somehow, for the first time, it has stopped feeling entirely impossible. And so we leave Alpha Centauri the way we will leave every stop on this journey, with more questions than answers, and a quiet backward glance. 3 suns, a rocky world where rain might once have fallen, and a temperamental little star that may have burned it clean. Our nearest neighbor turns out to be neither the welcoming twin of science fiction nor an empty dead rock, but something in between, and far more interesting than either, a real place, close enough to dream of, strange enough to keep us wondering. The nearest star we can actually watch moving across our sky, though, lies in an entirely different direction, and it travels faster than any other star we know. Chapter 3: Barnard's Star and the Ocean That Might Hide Beneath the Ice. We turn now away from the brilliance ahead of us and towards something almost its opposite, a star so faint that for most of history no one knew it was there at all. About 6 light years away sits a small, faint red dwarf known as Barnard's Star. It gives off barely 1,000th of the sun's light, a dim red coal of a star, so faint that you will never once glimpse it by simply looking up, no matter how dark your sky. And yet, in the quiet world of astronomy, Barnard's Star is genuinely famous, and it is famous for one thing above all. It moves. Every star in the sky drifts, very slightly, over the ages, but Barnard's Star races. It crosses our sky faster than any other star we know, sliding the full width of the moon against the background of more distant stars in roughly 180 years. That may not sound quick, but for a star, it is a headlong sprint. An astronomer who photographs it at the start of a career, and again near the end, can actually see how far it has shifted with their own instruments within a single working lifetime. It is racing toward us right now at over 140 kilometers a second, and it is drawing closer. In a few thousand years, this faint red ember will have crept in to become one of our very closest neighbors of all, and for a while, it will hold that title. Try to picture that speed for a moment. 140 kilometers every single second, fast enough to cross the entire width of our own planet in less than a minute, and it holds that pace without pause, year after year, century after century, silently closing the distance between us. We will not be here to greet it when it arrives at its nearest. Whole civilizations will rise and fall in the time it takes this one dim star to complete its approach, and yet it comes on, steady and patient, a slow red traveler on a journey measured not in years, but in the lifetimes of species. There is something quietly moving in that thought, that the arrangement of stars around us is not fixed and eternal, but slowly reshuffling, and that our list of nearest neighbors will look different long after we are gone. There is something worth sitting with in that slow, relentless motion. We tend to picture the night sky as permanent, the same constellations our grandparents saw, the same ones our distant descendants will see. But that permanence is only an illusion of the short time we each get to look. Give it long enough, and stars like Barnard's redraw the map entirely. The familiar shapes we trace overhead will slowly stretch and break apart. New neighbors will drift in close, and old ones will wander away into the dark. The sky is not a painting. It is a slow, silent river, and we only ever see one still frame of it, the one that happens to fall within a single human life. Barnard's star is simply the fastest of these silent swimmers, the one moving quickly enough that we can actually catch it in the act within a lifetime. But every star up there is drifting, each on its own long path, the whole pattern slowly flowing and rearranging over spans of time, so vast they make a human life look like the blink of a shutter. The constellations you learned as a child are not eternal. Given enough time, hundreds of thousands of years, millions, they will stretch and sag and dissolve, and new shapes we have no names for will take their place. We are lucky, in a way, to catch the sky in the particular arrangement we did. It is ours, this frame of the river, and it belongs to no one who came before us, and no one who will come long after. For a long time, this ancient star, and it is ancient, perhaps 10 billion years old, one of the oldest stars we have ever identified, older than the sun by more than twice over, seemed to be a lonely traveler, racing through the dark with nothing to keep it company. Then, only recently, that changed. And the way it changed is a good and humbling lesson in how carefully we have to hold everything we think we know about these distant places. For years, there was a claim of a single large planet circling Barnard's star on a cold, far-flung orbit. It was an exciting idea, and it was reported widely, but it did not survive closer inspection. The signal, studied more carefully, simply melted away. Then, in 2024, astronomers turned an extraordinarily sensitive instrument mounted on one of the giant telescopes in the Chilean desert, toward the star and watched it for 5 patient years. What they found was something quite different from the old claim: a tiny world, less than half the mass of Earth, whipping around the star in just over 3 days. And they did not stop there. By 2025, follow-up work had revealed not one planet, but a family of 4, every one of them smaller than Earth, all of them orbiting very close to their dim red star. So Barnard's star does have a planetary system after all, right here on our doorstep. But there is a catch, and it matters. Every one of these little worlds hugs its star so tightly, circling in a matter of days, that they are almost certainly far too hot and far too battered by their star's light to hold on to any atmosphere. As far as we can tell, not one of them could support life. The doorstep has worlds on it, but the door is sealed shut by heat. It is a small disappointment, and an honest one, and worth sitting with rather than rushing past. We would love for the nearest systems to be brimming with gentle Earths. But the universe owes us nothing, and again on this journey, it hands us worlds that are close and real and fascinating and simply not habitable. That is not a failure of the search. It is the search working exactly as it should, trading comforting fantasies for genuine knowledge, one careful measurement at a time. Barnard's 4 little worlds are not places we could live, but they are real, and they are ours to know. And a few years ago, we did not even know they were there. Knowing a true thing, even a disappointing one, is its own kind of quiet gain. And there is a strange warmth in that hidden ocean idea that stays with you as you travel on. The thought that even here, around a cold, dim star that will never warm a surface, life might still find a way in the dark, tucked beneath the ice, patient and unseen. We do not know that it is there. Almost certainly, around Barnard's little worlds, it is not. But the possibility itself, carried out into the emptiness, changes how the whole journey feels. The dark is no longer simply empty. It is full of maybes. And a sky full of maybes is a very different sky to travel under than a sky full of certain nothing. It is what keeps us building telescopes, keeps us leaning out into the cold, keeps this whole long search alive. Not the answers we have, but the maybes we have not yet ruled out. And yet the deeper idea that first drew our attention to cold, dim stars like this is still worth holding on to, because nature has quietly shown us that it can be true, just not always in the place we first went looking. To see how, we do not even have to leave home. Think of our own solar system, far out past Jupiter and Saturn. There, the moons Europa and Enceladus are frozen solid on the outside, their entire surfaces locked beneath shells of ice, sitting in cold and darkness far from the sun's warmth. By every simple measure, they ought to be dead worlds. But they are not. Beneath that ice, the constant pull and squeeze of their planet's gravity kneads their interiors and keeps them warm, and there, hidden away from the cold and the dark, sheltered under kilometers of ice, are genuine oceans of liquid water. Some of the most promising places to search for life in our entire solar system are not the warm, sunlit worlds we might picture at all. They are these frozen moons, with hidden seas tucked quietly underneath. There is a strange comfort in that idea, and it is worth resting on for a moment. It means that a world does not have to look welcoming to be alive. It does not need blue skies, or warm sunlight, or oceans lapping at open shores. Life, if it is anything like the stubborn, resourceful thing we know on Earth, might take hold in the most unpromising darkness, in a black sea beneath a roof of ice, warmed only by the slow flexing of a moon, lit by nothing at all. If that is true, then the number of places worth searching swells enormously. Every frozen world, every dim red dwarf's cold companion, every lonely wanderer far from any sun, becomes a place where the light might simply be on the inside, waiting, hidden, patient. We have been looking for other Earths, but we may have been looking for the wrong thing. The living worlds, if they are out there, might not look like home at all. So when we look at a cold, dim system like Barnard's star, the real lesson is not that life is impossible out here in the dark. It is that life, if it exists in places like this, may not be waiting for us on bright, warm, sunlit surfaces where it would be easy to spot. It may be hiding beneath ice, beneath rock, in warm and quiet water that never once sees its star. We have not found it there. We may never. But we have at least learned something important on our own doorstep: never to mistake a frozen surface for a dead world. Sometimes the light is simply on the inside. On the far side of the sun waits the exact opposite of this dim, quiet ember, the single brightest star in all of our night sky. Chapter 4: Sirius, the diamond of the sky, and the ghost beside it. From the faintest star in our journey, we now turn to the very brightest. Everything about Barnard's star is quiet, dim, and easily overlooked. Sirius is its opposite in every possible way. It is the brightest star in our entire night sky, blazing down at us from about 8.5 light years away, so brilliant and so unmistakable that ancient cultures across the world built calendars, myths, and whole seasons around its rising. The Egyptians watched for it to herald the flooding of the Nile. Sailors steered by it. If any star beyond the sun has shaped human life, it is this one. For the ancient Egyptians, its first appearance in the dawn sky each year came just before the Nile began to rise and flood their fields, and so this single star became a kind of celestial clock, marking the turn of their whole agricultural year. Cultures across the world wove it into their calendars, their navigation, their myths of the seasons. For thousands of years, before anyone knew what a star truly was, people ordered their lives in part by this one brilliant point of light. There is something moving in that long before we understood the stars at all, we still leaned on them, still let them shape how we lived. Sirius has been keeping time for human beings since long before human beings knew what it was. And yet, like so many of our neighbors, what looks to the eye like a single dazzling point of light is really two stars keeping close company in the dark. The star we actually see, the one doing all that blazing, is Sirius A. It is a hot, blue-white sun, about twice the mass of our own and considerably larger across. Its surface burns at nearly 10,000 degrees, almost twice as hot as the sun's face, and it pours out around 25 times more light than our star does. It is a genuine beacon, a lighthouse in our corner of the galaxy, but hidden in its glare, drowned out for centuries by all that brilliance, is something small, faint, and utterly remarkable. A companion star called Sirius B. Sirius B is a white dwarf, the burnt-out, collapsed core of a star that has already lived its life and died. And it hides one of the most staggering facts in our whole neighborhood. This little star is only about the size of the Earth, a small ball, no bigger across than the planet under your feet. And yet, crushed into that tiny sphere, it holds nearly as much mass as our entire sun. Try to hold those two facts together in your mind, because they do not want to sit together. The size of the Earth and the weight of the sun packed into the same object. The matter inside it is squeezed so impossibly tight that a single spoonful of it, scooped out and brought here, would weigh several tons on Earth, as much as a car balanced on a teaspoon. This is not ordinary matter anymore. It is stellar ash, the compressed cinder of a dead star, packed to a density almost beyond what the mind can picture. The story of how we even found that faint companion is a small marvel in itself. For a long time, no one saw Sirius B at all, but astronomers watching the bright star noticed something strange. Sirius A was not moving in a straight line through the sky. It wobbled ever so slightly, as though something unseen were tugging at it. Long before anyone laid eyes on the companion, they knew, from that gentle swaying alone, that a hidden mass had to be there, pulling on the star we could see. Only later, with better telescopes, was the tiny white dwarf finally caught, glimmering right where the wobble said it must be. It is a lovely reminder of how much of this neighborhood we have mapped, not by looking directly, but by watching what the dark does to the light around it, reading the invisible from its fingerprints on the visible. So much of astronomy turns out to work this way. We rarely get to see the thing itself. We see its shadow, its pull, its faint effect on something brighter beside it. A planet betrays itself by the tiny wobble it gives its star, or the sliver of light it blocks as it crosses in front. A dead companion reveals itself by tugging its living partner off a straight line. Whole invisible worlds are mapped from nothing but the gentle disturbances they leave in the light we can see. There is a kind of patience and humility in that method, a willingness to sit and watch and infer, to trust that the universe leaves honest fingerprints even on the things it hides. Almost everything we know about our neighborhood, we learned not by reaching out and touching it, but by looking very carefully at what refused to stay perfectly still. And there is a quiet, almost poignant twist hidden in this pair of stars. You might naturally expect the faint, dead companion to be the younger of the two, the one that never quite grew up. It is exactly the other way around. Sirius B was once the heavier of the pair, a star perhaps 5 times the mass of the sun. And here is the cruel arithmetic of the cosmos. The heavier a star is, the faster it burns through its fuel, and the sooner it dies. So the more massive star raced through its whole life, swelled up, and collapsed into the white dwarf we see today, around 120 million years ago, while its lighter, more patient partner is still shining away in the prime of its life. The star that looks older and deader is the one that was, in truth, born to burn out first. Brilliance and brevity tied together. It is a pattern that repeats all across the cosmos, and there is a quiet lesson in it for us. The brightest, heaviest, most spectacular stars are almost always the ones that die youngest. They burn with such fury that they exhaust themselves quickly, blazing gloriously, and then guttering out, sometimes in only a few million years, a mere eye blink in the life of the universe. The small, dim, unremarkable stars, the ones nobody writes myths about, are the ones that endure. A little red dwarf like Barnard's or Proxima can burn steadily for tens or even hundreds of billions of years, far longer than the universe has so far existed. So the sky plays a quiet trick on us. The stars that catch our eye, the dazzling ones, are the brief ones, and the faint ones we overlook are the ones that will still be shining long after the beacons have gone dark. There is something almost gentle in that, a reminder that lasting and dazzling are rarely the same thing, out here or anywhere. So what lies ahead for bright Sirius A, still blazing in its prime? Here we have to be careful, because it is very easy to reach for a dramatic ending that simply is not true, and this is exactly the kind of place where stories about space so often go wrong. Sirius A will not explode. It will not end its life in a supernova. To die that violent way, a star needs to be at least 8 or so times the mass of the Sun, and Sirius A, at around 2 solar masses, falls far short of that mark. Its fate is gentler and slower, and in its own way more beautiful. In a few 100 million years, it too will swell up into a red giant, its outer layers billowing outward, and then it will gently shed those layers into a soft, glowing shell of gas, leaving behind only its own dense, hot core. And that core will settle down over the long ages into a white dwarf, following the very same quiet path its companion has already walked before it. In the far distant future, this dazzling diamond of our night sky will become a second pale ember, and the two of them will drift on together as a pair of dead stars, circling each other in the dark, long after anyone is left to name them. There is a strange tenderness in imagining that far future. The brightest star in all our sky, the one that has guided sailors and inspired myths for as long as there have been people to look up, will one day simply go quiet, not in a blaze, not in a catastrophe, but gently, swelling, cooling, letting go of its outer layers, and settling into a small warm cinder that slowly, over billions of years, fades toward black. Everything shines for only a while. Even the brightest beacon in our heavens is, in the end, just passing through its moment of brilliance, on its way to the same quiet dark that waits for every star. Somehow, that does not make Sirius less beautiful. If anything, knowing it will not last forever makes its blaze feel a little more precious. There is a lesson in that we can carry back down to earth with us, if we like. Nothing that shines, shines forever. Not stars, not worlds, not the brief, bright span of a life. And that is not a sadness so much as the very thing that gives light its value. A sun that burned unchanged for all eternity would be a kind of furniture easy to ignore. It is precisely because Sirius will one day fade, because our own sun will one day change, because none of this is permanent, that any of it is worth looking up at all. The impermanence is not the flaw in the beauty. It is the reason there is any beauty to notice at all. So we leave Sirius still blazing, still the brightest jewel in the sky, and carry that small quiet truth onward with us into the dark. Everything out here is passing through its own bright moment, ourselves included. That is not a reason for sorrow. It is the very thing that makes the whole crowded, shining, temporary sky worth crossing. A short course correction now carries us onward, to a small red star that hides not one world, but three. Chapter 5. Wolf 161. One star and three rocky worlds. About 14 light-years from Earth glows another dim red dwarf, this one called Wolf 161. On its own, it would be entirely unremarkable, just another faint, cool, long-lived star among the countless red dwarfs that quietly fill our neighborhood, the kind of star we have already learned to look past. But this one is not empty-handed. It carries a small family of planets, and those planets tell a quietly profound story about how differently worlds can turn out, even when they are born around the very same star from the very same cloud. 3 rocky planets circle Wolf 1061, and each one has met a very different fate. The innermost is a scorched, punished world, orbiting so close to its star that one side very likely faces it forever. One hemisphere baked in permanent, blistering daylight, the other locked in endless frozen night, with no sunrise or sunset ever crossing between them. The outermost planet follows a stretched, uneven orbit that never quite settles into comfort, swinging closer and then farther as it goes. But it is the middle world that makes astronomers lean in and pay attention. It is called Wolf 1061c, and it sits, remarkably, inside the habitable zone. Wolf 1061c is what we call a super-Earth, a rocky planet noticeably more massive than our own, weighing in at around 3.5 times the mass of Earth. It circles its star once every 18 days, close enough to its dim red sun to stay warm, but not so close that it is roasted like its unfortunate inner sibling. When it was first announced, back in 2015, it was the nearest potentially habitable world we knew of anywhere, though in the years since, we have found a small handful of candidates closer still. Whether it could truly host life remains genuinely uncertain, and it is worth being honest about that uncertainty rather than promising more than we know. But it sits squarely in that narrow, precious band where liquid water is at least possible, and that alone makes it one of the more tantalizing addresses in our entire neighborhood. And standing on such a world would feel unfamiliar in your very bones, literally. With more than 3 times the mass of Earth, its surface gravity would pull on you noticeably harder than the gravity you have known your whole life. A person who weighs 70 kilograms at home, a little over 150 pounds, would feel distinctly, tiringly heavier there. Every step would take more effort. Lifting your own arm would feel like a small chore. Your body would feel constantly reminded that it was standing on a world that grips harder than the one it grew up on. And above you, that red dwarf sun would hang large and deep orange in the sky, its light dim and ruddy and warm, never quite reaching the brilliance of our own noon. It would cast long, coppery shadows across the ground at every hour of the day. Picture it, a quiet, heavy world, under a quiet, patient star, bathed forever in a kind of permanent, golden late afternoon light that never quite becomes either morning or evening. And that permanence has a strange beauty to it if you let yourself sink into the thought. On such a world, if it faces its star the way its scorched inner sibling does, there would be no sunrise and no sunset at all. The red sun would simply hang in one fixed place in the sky, unmoving, for as long as you cared to watch, century after century, in exactly the same spot. There would be a place on that world where it was always dawn, frozen at the horizon, and a place where it was always deep night, and a narrow ring between them, a band of endless ruddy twilight, where any gentle weather and any liquid water would most likely gather. Astronomers actually have a name for that thin habitable band on a locked world, the terminator, the dividing line between the eternal day side and the eternal night side. It is one of the stranger places to imagine life taking hold, not spread across a whole warm world as it is on Earth, but strung out along a single ring of permanent sunset, caught forever between fire and ice. Step too far toward the sun, and you burn. Step too far away, and you freeze. But in that narrow ribbon of dusk, if an atmosphere could carry the warmth around and soften the extremes, there might just be room for something to live, hugging the twilight, following the one gentle line on an otherwise unlivable world. It stretches the imagination to picture what a living thing there might even be like, shaped by a sun that never moves, a landscape with no days, warmth on one side and cold on the other, and the only mildness a thin line running clear around the world. If life arose in such a place, it would know nothing of morning or evening, nothing of the turning of a day. Its whole sense of the world would be built around that unmoving red sun and the fixed, gentle band beneath it. We so often imagine alien life as a version of ourselves. But worlds like Wolf 1061c are a reminder that life, if it exists out here at all, might be shaped by rules so different from our own that we would struggle even to recognize the questions it asks of its own strange sky. Imagine living your whole life in that thin ring of permanent dusk, under a sun that never rises and never sets, in a stillness our restless spinning earth has never known. It is a kind of peace almost impossible for us to picture, and a reminder that even the rhythm of day and night, which feels so fundamental to us, is just one way for a world to be. We take our days and nights so completely for granted. The reliable rising and setting of the sun, the turn of morning into evening, is woven into everything we are, our sleep, our stories, our sense of time itself. And yet it is not a law of the universe. It is just a happy accident of how fast our particular world happens to spin. Out here, around other stars, there are worlds locked still, worlds that never turn, worlds bathed in permanent day or permanent night, or frozen forever in a single unchanging dusk. Our gentle cycle of light and dark, the thing that feels most ordinary about a day, turns out to be one of the rarer and stranger gifts of home. There is a quiet lesson tucked into this one small system, and it is worth carrying with us for the rest of the journey. 3 worlds born together from the same swirling disk of gas and dust around the same star, and yet they could hardly have turned out more differently. One is a scorched, half-frozen prisoner locked facing its sun. One rides a restless, uneven path, and one sits in the gentle middle ground where water might just survive. It did not take different stars to make such different fates. It only took slightly different distances, slightly different orbits, and our own solar system is exactly the same kind of story: scorched Mercury, gentle Earth, and frozen Neptune, all children of one sun, all utterly unalike. Small differences, compounded over billions of years, are the difference between a desert and an ocean, between a dead rock and a living world. It makes you look at our own comfortable place around the sun a little differently, as something that could so easily have been otherwise. and it puts the whole search for other worlds in a humbling light. When we scan these distant stars for planets in the habitable zone, we are really asking a very narrow question. Is there a place where the numbers happen to line up the way they lined up for us? A world not too close and not too far, not too heavy and not too light, around a star not too fierce and not too dim, holding on to just enough air and just enough water for long enough. So many small things had to fall into place for Earth and stay in place for billions of uninterrupted years that when you lay them all out, it starts to look less like an ordinary outcome and more like a long, improbable run of good fortune. That does not mean we are alone. The galaxy is vast, and vastness has a way of making even rare things happen somewhere. But it does mean that a gentle, living world is a delicate achievement, not a given. Wolf 1061's three siblings, so different from one another, are a small reminder of just how many ways a world can go wrong, and how few ways it can go right. And traveling on from that thought, we carry a gentler appreciation for the ground beneath us. Earth did not have to be temperate. It did not have to hold on to its air, or its water, or its steady tilt, and its life-giving distance from the sun. It simply did, and kept doing so, for the billions of uninterrupted years that life needed. Every world we visit that failed to manage that same quiet trick makes our own success look a little less ordinary, and a little more like a small, improbable grace we happen to be born into. This star, so easy to overlook, sits right at the very edge of something enormous that we are all sailing through at this very moment. And most people go their whole lives without ever learning its name.